scientists have realized something profound. If aliens exist, we won't find them by waiting for contact. We'll find them by recognizing their technology. The infrared glow of structures that harvest entire stars, communication networks that use particles passing through planets like they're not even there, chemical signatures visible from 1,000 light-years away. The tools we're developing right now could revolutionize our understanding of whether we're alone in the universe. And here's the mind-blowing part. The proof might already be hidden in data we're collecting right now. Imagine a civilization facing the ultimate energy crisis. They've exhausted their planet's resources and need exponentially more power. There's only one solution: harvest their star's entire energy output. Our sun produces more energy in 1 second than humanity has used in all of recorded history. A civilization that captures even a fraction of that power could sustain itself for millions of years. This would represent a Type 2 civilization on the Kardashev scale, capable of harnessing the entire energy output of their star. In 1960, physicist Freeman Dyson proposed that advanced civilizations might build swarms of collectors around their stars. Not solid shells, but millions of structures, each potentially larger than Earth, orbiting in coordinated formations. Here's what's incredible. We can detect these megastructures right now. When they pass in front of their star, they create dimming patterns unlike anything in nature. In 2015, astronomer Tabitha Boyajian discovered something extraordinary. A star 1,400 light-years away was dimming by up to 22% in completely irregular patterns. To put this in perspective, if Saturn passed directly in front of our Sun, it would dim the light by only 12%. The discovery ignited worldwide fascination. Scientists and media outlets speculated about alien megastructures. After years of investigation involving over 200 researchers, the leading theory suggests dust clouds from disintegrating comets caused the dimming. Even though aliens weren't the answer this time, Boyajian's star taught us something crucial. We now have the technology to detect massive structures around distant stars. The James Webb Space Telescope is analyzing this data right now and can detect the infrared signatures that any Dyson sphere would inevitably produce. If they exist, we'll find them. But harvesting stars is just the beginning. What if they're using them as communication tools? Advanced civilizations face a fundamental challenge. How do you communicate across the galaxy? Radio waves spread out and weaken over vast distances, but lasers can be focused into beams that maintain their intensity across thousands of light-years. A sufficiently powerful laser pulse could outshine an entire star for brief moments, making it detectable from anywhere in the galaxy. But the concept becomes truly extraordinary when you consider coordinated networks, fleets of laser beacons sweeping across space like cosmic lighthouses. From your perspective on Earth, you'd see stars brightening and dimming in synchronized sequences across different regions of the sky, patterns that would be unmistakably artificial. The Vera Rubin Observatory in Chile is creating a real-time movie of the universe right now, photographing the entire visible sky every 3 nights. If artificial galactic communication networks exist, we're developing the tools to recognize them. But there's something even more extraordinary than laser networks. Aliens might be communicating through particles that are passing through your body at this very moment. Right now, as you're watching this video, trillions of neutrinos are passing through your body every second. These ghost particles can travel through entire planets without slowing down. You can't feel them, but they're there, and they might be carrying messages from alien civilizations. For an advanced civilization, this presents an incredible opportunity. Unlike any other form of communication, neutrinos can pass through anything: planets, stars, dust clouds. A civilization using neutrino networks could send messages anywhere in the galaxy without interference. In 2012, scientists at Fermilab proved this concept by encoding and transmitting the word neutrino through 240 meters of solid rock. The receiving detector successfully decoded the message from the neutrino beam, proving that solid matter poses no barrier to this form of communication. It was humanity's first neutrino message. The engineering challenges are immense. Scaling this to interstellar distances would require focused beams with energies equivalent to the output of entire stars. But for a civilization that has mastered stellar engineering, such power levels become conceivable. The Ice Cube Observatory in Antarctica is monitoring a cubic kilometer of ice for neutrino interactions right now. Natural neutrinos arrive randomly from cosmic sources. Artificial neutrino communications would show unique signals that look like encoded messages. Yet there's an even simpler approach that any civilization could use right now, one that requires no exotic physics, just the star they already have. Look up at the night sky tonight. What if some of those stars aren't just shining? What if they're talking? Here's an elegantly simple concept. Instead of generating enormous energy to send signals, use your star as a giant signal lamp. By placing massive structures in coordinated orbits, a civilization could create deliberate dimming patterns visible across the galaxy. Think of it as cosmic Venetian blinds. The star becomes a broadcasting station, blinking messages in mathematical sequences that any civilization with telescopes could detect. The Transiting Exoplanet Survey satellite is monitoring over 200,000 stars continuously right now, sensitive enough to detect artificial dimming patterns. The key is distinguishing these from natural phenomena. Machine learning algorithms are analyzing stellar data at this very moment, searching for patterns too complex to be natural. The most intriguing possibility is coordinated signaling across multiple star systems, a galaxy-wide network where stars blink in perfect synchronization. But what if we don't need to find living civilizations at all? What if we could detect the ghosts of dead worlds through something as simple as their pollution? We're looking for something surprisingly mundane: alien pollution. Any industrial civilization would contaminate their atmosphere with artificial chemicals that don't exist in nature. The James Webb Space Telescope can detect these chemical fingerprints from hundreds of light years away right now. We can spot pollution from a civilization similar to Earth in the 1980s, even from across the galaxy. But here's what's remarkable: we don't need to find living civilizations. Some industrial chemicals persist for thousands of years: chlorofluorocarbons, certain nitrogen compounds, and synthetic molecules that nature never produces. We might detect the atmospheric fossils of civilizations that vanished long ago, conducting archaeology from light years away, studying the chemical remnants of dead worlds. And this brings us to the most profound realization of all. We might be living through one of the most important moments in human history. All 5 detection methods are coming online simultaneously. We're not waiting for aliens to contact us. We're hunting for the technological signatures they cannot avoid creating. These aren't just detection methods. They're predictions about our own future. Every technology represents a path our civilization might follow. If we detect alien technology, we're not just proving we're not alone. We're discovering that civilizations can survive their own development. The hunt for alien technology represents humanity's greatest endeavor. We're using our most advanced instruments to answer the most profound question: are we alone? With revolutionary telescopes and detection methods, we have unprecedented ability to find technological signatures across the galaxy. First contact might not be a message or a visit. It might be recognizing alien engineering in telescope data. We might discover we're not alone by analyzing infrared signatures, detecting synchronized laser flashes, or finding industrial pollution in a distant atmosphere. The search is accelerating faster than ever before. The universe is vast, but our ability to explore it grows exponentially. Somewhere out there, civilizations might be using technologies we're only now learning to detect. What do you think? Are we on the verge of the greatest discovery in human history? Which of these 5 methods do you think will find aliens first? Share your thoughts in the comments below, and don't forget to subscribe and hit the bell to stay updated.